Alright, let's start the Advanced SQL in Kaggle. I might have to break this down to two parts, depending on how exhausted I get. But hopefully I can do it in just one. It says 4 hours there, so I'm not sure. So introduction. In the intro to SQL microcourse, you learn how to use inner join to consolidate information from two different tables. Now we'll learn about a few more types of join, along with how to use unions to pull information from multiple tables. Along the way, we will work with two imaginary tables called owners and pets. Each row of the owners table identifies a different pet owner, where the ID column is a unique identifier. The pet ID column in the owners table contains the ID for the pet that belongs to the owner. This number matches the ID for the pet from the pets table. For example, the pets table shows that Dr. Harris Bonkers is the pet with ID 1. So here, ID 1. The owner's table shows that Albert Little is the owner of the pet with ID 1. Putting these two facts together, Dr. Harris Bonker is owned by Albert Little. Likewise, Miss Veronica Dunn does not have a corresponding pet ID. She does not have a pet. And since 5 does not appear in the pet ID column, Maisie does not have an owner. Joins. Recall that we can use an inner join to pull rows from both tables, where the value in the pet ID column in the owner's table has a match in the ID column of the pets table. In this case, Veronica Dunn and Maisie are not included in the results. But what if we instead want to create a table containing all pets, regardless of whether they have owners? Or what if we want to combine all of the rows in both tables? In these cases, we need only use a different type of join. For instance, to create a table containing all rows from the owner's table, we use the left join in this case. Left refers to the table that appears before the join in the query. Right refers to the table that is after the join. So, as O inner join, SP, left table, right table. Replacing inner join in the query above with left join returns all rows where the two tables have matching entries, along with all of the rows in the left table, whether there is a match or not. So it maintains the left and joins on the matches. If we instead use right join, same thing, but maintains the right. Finally, a full join returns all rows from both tables. Note that in general, any row that does not have a match in both tables will have new entries for missing values. So it's similar to Panda's merge function. Unions. As we've seen, joins horizontally combine results from different tables. If instead of like to vertically concatenate columns, we can do so with a union. The example query below combines the age column from both tables. Note that with union, the data type of both columns must be the same, but the column name can be different. So for instance, we cannot take the union of the age column from the owner's table and the pet name column from the pet's table. We use union all to include duplicate values. You'll notice that line appears in both the owners and pet. And you use union all in the query to union distinct. If you like to drop duplicate values, use union distinct. Example, we work with record news data. So assume it's the same code as always in the beginning. There's a lot of redundant stuff in these tutorials, so I like to skip some parts of them. Since you are familiar with joins from the intro to SQL microcourse, you work with a relatively complex example of a join that uses a common table expression. The query below pulls information from the stories and comments tables to create a table showing all stories posted on January 1st, 2012, along with a corresponding number of comments. Use the left join so that the results include stories that didn't receive any comments. So there's the city with C as select parent count as comments. Don't be curious, group by parents. So here is selecting from the right table and joining the left. Selecting the columns that he wants to join. And the city is for the left. Find query, join query. And the query, so yeah, name here. Dot results, dot to data frame. Since the results are ordered by the none comments column, stars without comments appear at the end of the data frame. Remember that none stands for not a number. Next, we write a query to select all usernames corresponding to users who wrote stories or comments on January 1st, 2014. We use union distinct instead of union all to ensure that each user appears in the table at most once. To get the number of users who post on January 1, 2014, we need only take the length of the data frame. So it doesn't seem that complicated. So dataset, Stack Overflow project, table arrive, client list rows. You can run this already. And run this. How long does it take for our questions to receive answers? Did I do this? You're interested in exploring the data to have a better understanding of how long it generally takes for questions to receive answers. And with this knowledge, you plan to use this information to better design the order in which questions are presented to Stack Overflow users. With this goal in mind, you write the query below, which focuses on questions asked in January 2018, returns a table of two columns. Q ID, the ID of the question, time to answer, how long it took in seconds for the question to receive an answer. Run the query below without changes. Take a look at the output. So supposed to be like this. So selecting from this column, q.id, sqid. I don't know. Maybe this is the minimum. Yeah. Timestamp diff. Probably another function. Creation date, creation date second as time transfer. BQ SQ. Then does the inner join with the answers as a, and it specifies where it's gonna join, which is on the ID. And the dates are on strings. You're surprised at the results and strongly suspect that something is wrong with your query. In particular, according to the query, 100% of the questions from January 2018 received an answer. But you know that 80% of the questions on the site usually receive an answer. Total number of questions is surprisingly low. You expected to see at least 150,000 questions represented in the table. Given these observations, I think that the type of join you have chosen has inadvertently excluded unanswered questions. In the code saw below, can you figure out what type of join to use to fix the problem so that the table includes unanswered questions? Note, you need only amend the type of join. So it's pretty much copy paste this and change the join. So I don't remember really well if the other types I need to specify things. So let me see the store. Yeah, so it's the same thing. So yeah, it makes sense actually. Now that I think about it, because if you're gonna join from left or right, you need to specify. But what if I wanna do a full join? I don't think they showed here. Because a full join doesn't make sense to specify. Yeah, so union all. Oh no, union is vertically. So let me just try both. Don't spend time thinking about the problem itself. Just learn the SQL part. Correct, okay. Initial questions and answers, part 1. We're interested in understanding the initial experience that users typically have with the Stack Overflow website. Is it more common for users to first ask questions or provide answers after signing up? How long does it take for users to first interact with the website? To explore this further, you draft a partial query in the code cell below. The query returns a table with 3 columns: owner user ID, key, creation date, the first time the user asked a question, a creation date, the first time the user contributed an answer. You want to keep track of users who have asked questions but have yet to provide answers. And your table should also include users who have answered questions but have yet to pose their own questions. With this in mind, please fill in the appropriate join, i.e. inner left, right, or full, to return the correct information. Note you will need only fill in the appropriate join. Other parts of the query should be left as is. You also don't need to write any additional code to run the query, since the check method will take care of this for you. So again, I need to select the right type of join here. So it's going to be either left or right because it has specified here the columns. I assume it's going to be right because the previous one was left. So am I missing here something? So maybe it's left. Can't be full. That should be left. What? Oh, I forgot the inner as well. Maybe I'm forgetting the join, inner join. Yeah, right join, I think. See on the previous one. Yeah. Forgot the join there. It's probably right by deduction. Yeah, correct. So let's see. Selects the columns here. Uses this bin function again, which has to do with the problem. Then right join the other column. And here specifies the column that it wants to join. Archive creation, blah blah. Initial questions and answers part 2. Now we'll address a more realistic and complex scenario. Just these questions, you need to pull information from 3 different tables. The syntax varies. This syntax varies similar to the case when this is weirdly written. I think. To the case when we have to join only 2 tables. For instance, consider the 3 tables below. We can use 2 different joins to link together information from all 3 tables in a single query. So select. So P and T are different tables, I guess. Specifies here SP full join. Also, you write full join here. Does full joining these 2 tables P and O on the ID, and left joining the remaining one on P. With this in mind, say you're interested in understanding users who joined the site in January 2019. You want to track their activity on the site. When did they post the first questions and answers, if ever? Or a query that returns the following columns. ID. The IDs of all users who created Stack Overflow accounts in January 2019. January 2019 to 31 2019 inclusive. Key creation date. First time the user posted a question on the site. If the user has never posted a question, the value should be null. First time the user, so I have to create this query. So I was gonna have select and then the specifications. The following columns. The biggest issue is these problems here. That I'm not interested in paying attention to the problems, just the functions, so I can finish this as fast as possible. So notice the questions answer. All users who join is nothing should be included. The query from the previous questions should be a nice starting point to answering this question. We need to use the post answers and post questions tables. So I'm gonna make answers add a dot q creation date a dot the first time the user posts a question. The first time the user posts a question on the site. So this is question and this is answer. So they shouldn't have this one. I think. Not sure. Then I'm gonna make from the backticks. I'm just gonna copy there. It's gonna be project first and dataset and table. It's gonna be answers here. Then I'm gonna make the type of join, which I'm just gonna guess. But I think it's like this, inner join. This with questions. And then I forgot. Oh, on a dot id was q dot id. I think it's like that. You need to use the post answers and post questions tables. You also need to use the users tables from the Stack Overflow dataset. The relevant column from the users table are ID and creation date when the user joined the Stack Overflow site in datetime format. So I'm gonna need to use the other one. And this is a pain to think about. So I probably need to join like this, two of them, and then join the third one. I just forgot the. You need to use this as ID. Inner join here. Oh, so I forgot this as well. Let's answer and ask question. And then here is just left join. And then the rest is just details of which ones that I want of the which information I want to keep. But the important part is understanding the joins there, which I think I get it. Inner join joins on the same column and it puts them together. Left join keeps the left one and joins with the right on the table specified columns. Right is the other way around. And then full join keeps all the columns on the both tables. So as u on u a.id and equals to u.id. So now I just need to remember what's the table of the other table that they want me to join there. Post answers, post questions. You also need to use the users table from the Stack Overflow dataset. The relevant columns from the users table are ID and creation date. So maybe I need to specify that this as well here. But here is not saying anything. And this is just joining two of them. So which one is the user one? I don't care that much, to be honest. Just gonna run this, probably gonna fail. I'm gonna look at the hints and answer. So here, let me see. So the only difference here is they did the U first. Oh, and they did this min here. Which I don't understand really well what it is, but assuming is the minimum, takes the minimum of the column. It's a function to take the minimum. From BigQuery. Oh, so this is the one. Here. It should be going here. But they did the other way around. So BigQuery public data SA on u.id and a dot. So here is a dot owner user ID. Because I'm supposed to join on different column. Group by ID. So I'm just gonna do it like they did here. There's a comma as well. So yeah, because this is a part of a selection. And then I need to change the things here, the data sets. About this. Okay, now let's test. So it's not in the join. I'll try one more. If it's not, then. So maybe I'll try full join here. Then right join there. And I think the rest is correct. The way that I'm doing there. Yeah, so left join, left join. What? So it probably did something wrong as well. Oh, is the UID a owner? So it's this portion here. Maybe the order matters as well. UID should come first. But I don't think it does. Oh, maybe actually it does. Yeah, on a practical level, it probably does because you're changing which one is referencing who. How many distinct users posted on January 1, 2019? Oh, and I said that because it's only one equal value here. So one equal values is the assignment operator. If it was double true equals values, then it would be checking for equality. But maybe SQL might be different as well. Because it doesn't make much sense to assign this through this. Maybe it does actually. Now I'm not sure. How many distinct users posted on January 1, 2019? Console below, write a query that returns a table with a single column. Under user ID, the ID of all users who posted at least one question or answer on January 1, 2019. Each user ID should appear at most once. So select owner user ID from I think it's the user. Yeah, that should be. The user where extract. Yeah, I think it's timestamp something. If this says, oh, maybe I don't need to do extract. But now I don't remember if I need to select the date as well. So it would be date equals to string and then the date that I want there. But it would be something like this. But I'm not sure if I need to do it like this. The post questions and post answers tables. You can get the ID of the original poster from the owner user ID column. Likewise, the date of the original posting can be found in the creation date column. In order for your answer to be marked correct, your query must use a union. No, so I need to join them vertically. So let me see. I think the union comes after the wire here. Yeah, maybe I should be using extract date from. Yeah, I think this makes more sense actually. But I don't know the column name. So where is the union here? I'm just gonna use this one as an example. Yeah, so it comes below here. And then I can try both. Just gonna copy this here. So oh yeah, I need to delete this. IDs of all users post the location. In the post question and post answers tables, you can get the ID of the original poster from the owner user ID column. Also, it's post answers union post. Post questions union post answers. Likewise, the date of the original posting can be found in the creation date column. No, creation date column. I always forget that I can't double click there. So, creation date. And then this is gonna be pretty much the same here, but it's just gonna change the data sets. At least I guess. I guess that's what I'm supposed to do. Post answers and post questions. Well done. Your answer does not have the correct number. That's what you have. So it's probably this thing here. Let's try again. Nice. We finally got one. Reduction in the intro to SQL microcourse, you learn how to use aggregated functions which perform calculations based on sets of rows. This story will learn how to define analytic functions, which I don't remember this. How to use aggregated function. Oh, I think it's count. Yeah, you're referring to count here. Learn how to define analytic functions, which also operate on a set of rows. However, unlike aggregated functions, analytic functions return a potentially different value for each row in the original table. Analytic functions allow us to perform complex calculations with relatively straightforward syntax. For instance, we can quickly calculate moving averages and running totals among other quantities. Syntax. To understand how to write analytic functions, we work with a small table containing data from two different people who are training for a race. The ID column identifies each runner. The date column holds the day of the training session, and time shows the time in minutes that the runner dedicated to training. Say we'd like to calculate a moving average of the training times for each runner, where we always take the average of the current and previous training sessions. Do this with the following query. So select this CTR, average time over partition by ID, order by date, rows between one preceding and current row as average time from this dataset. Analytic functions have an over clause, which defines the sets of rows used in each calculation. The over clause has three optional parts. The partition by clause divides the rows of the tables into different groups. The query above we divide by ID so that the calculations are separated by runner. So this separates by ID. The order by clause defines an ordering within each partition. The sample query ordering by date column ensures that earlier training sessions appear first. The final clause, rows between one preceding and current row, is known as a window frame clause. It identifies the set of rows used in each calculation. We can refer to this group of rows as a window. Actually, analytic functions are sometimes referred to as analytic window functions or simply window functions. More on window frame clauses. There are many ways to write window frame clauses. Rows between one preceding and current row, the previous row and the current row. Rows between three preceding and one following. The three previous rows, the current row, and the following row. Rows between unbounded preceding and unbounded following are rows in the partition. Of course, this is not an exhaustive list, and you can imagine that there are many more options. In the code below, you see some of these clauses in action. Three types of analytic functions. The example above uses only one of many analytic functions. BigQuery supports a wide variety of analytic functions, and we'll explore a few here. For a complete listing, you can take a look at the documentation. So I think I'm gonna research later as well which one's better to use, SQL or Pandas for machine learning. I think SQL is more for servers and Pandas is more for local stuff. That's the intuition I have, but might be off. Because depending on which one is more useful or used more, I'm gonna focus on that one instead. As you might recall, average from the example above is an aggregated function. The over clause is what ensures that it's treated as an analytic aggregated function. Aggregated functions take all of the values within the window as input and returns a single value. Min or max returns the minimum or maximum of input values. Average or sum returns average or sum. Returns the number of rows in the input. Analytic navigation functions. Navigation functions are assign a value based on the value in a usually different row than the current row. First value or last value returns the first or last value in the input. Lead and lag returns the value on a subsequent or preceding row. Analytic numbering functions. Numbering functions assign integer values to each row based on the ordering. Row number returns the order in which rows appear in the input, starting with 1. Rank, all rows with the same value in the ordering column receive the same rank value, or the next row receives a rank value which increments by the number of rows with the previous rank value. Each row of the table corresponds to a different bike trip, and we can use an analytic function to calculate the cumulative number of trips for each date in 2015. So does the city here, select date, start date as trip date, count, I think the stars first, select all as num trips from this data set, this table, where extract here from equals 2015 group by trip date. Select all, sum num trips, or over order by trip date, goes between unbounded preceding and current row as cumulative trips from trips by day. Okay. Think I understand, but not really sure still. The query uses a common table expression to first calculate data, then we use sum as an aggregate function. Since there is no partition by clause, the entire table is treated as a single partition. The order by clause orders the rows by date, where earlier dates appear first. Earlier dates appear first. So order by trip day. Okay, so it doesn't specify it. Maybe here, rows between unbounded preceding current row. Not sure. No, it's the order by. Yeah, it doesn't need to specify. By setting the window frame clause to rows between unbounded preceding current row, we ensure that all rows up to and including the current date are used to calculate the cumulative sum. Note, if you read the documentation, see that this is the default behavior, and so the query will return the same result if we left out this window frame clause. So they just did it for presentation purpose. So where was I here? Oh, here. Next query tracks the stations where each bike began. So let's say time, first value, then over, partition by bike number, order by state. Don't understand this partition really well, but use both first value and last value as analytic functions. So first value, last value. So first comes the analytic function, then it specifies where it's gonna apply that analytic function. Partition by clause breaks the data into partitions based on the bike number column. Since the column holds unique identifiers for the bikes. This ensures the calculations are performed separately for each bike. So I think I need to understand better what's partition. So I'm not sure if I really understand the meaning of this. Partition. Also is division. Makes sense. But the partition clause breaks the data into partitions based on the bike number column. But what does that mean exactly? That's why it's confusing. Does it mean it's on chunks of data here, or it organizes by this, but then isn't that what group by does? Maybe the partition by is the group by of the analytic function. It's just similar, but I'm not really sure that's the case. How can you predict the demand for taxes? Say you work for a taxi company and you're interested in predicting the demand for taxes. Towards this goal, you'll actually create a plot that shows a rolling average of the daily number of taxi trips. Amend the partial query below to return a data frame with two columns. Trip date contains one entry for each date from January 1st, 2016 to December 31, 2017. Average num trips shows the average number of daily trips calculated over a window, including the value for the current date, along with the values for the preceding 15 days and the following 15 days, as long as the days fit within the 2-year time frame. For instance, when calculating the value in this column for January 5, 2016, the window will include the number of trips for the preceding 4 days, the current date, and the following 15 days. This query is partially completed for you, and you need to only write the part that calculates the average number of trips column. Note that this query uses a common table expression, CTE. If you need to review how to use CTEs, you're encouraged to check out the intro course. So I need to complete this. So here goes the analytic, then it's going to be a partition by, and then order by. I think it's partition that's written, but I don't remember really well. Partition by contains one entry. So here's trip by day, trips by day, as selecting the date from this timestamp as trip date, getting the count as number of trips. So maybe here's partition by num trips, in order by trip day. Or maybe, yeah, I'm not sure. Start date. So it's probably gonna be trip date here. And here's the analytic function that I don't know which one they want me to use. Average. So maybe it's average. Num trips. I'm just guessing here, but I think that's correct. Your window should include the current date along with the preceding 15 days and the following 15 days. So maybe it's the other way around. Yeah, I don't know. Use the average function. So I'm using here. Write an over clause with that. Orders the rows with the trip date. The partition by trip date. Only uses a window that includes the 15 preceding rows. The current row and the following 15 rows. So that one I'm not sure about. Oh, it's probably this thing here. Let me check. Yeah, I'm not sure what they want me to do. Write an over clause with that. Orders the rows. Write an over clause with that orders the rows with the trip date column and uses a window that includes the 15 preceding rows. The current. So now how can I say current row? Maybe that's it. So let's see if I do this. As I'm just gonna look. It's probably there, the mistake. Also, here is correct. 15 preceding and 15 following. So order by trip date. So there's no partition here. That's correct. Can you separate an order just by community area? The query below returns a data frame with 3 columns from the table: pickup, community area, trip start timestamp, and trip end timestamp. Amend the query to return an additional column called trip number, which shows the order in which the trips were taken from their respective community areas. The first trip of the day originating from community area 1 should receive a value of 1. Second trip of the day from the same area should receive a value of 2. Likewise, the first trip of the day from community area 2 should receive a value of 1. So note that there are many numbering functions that can be used to solve this problem, depending on how you want to deal with the trips and trips that started at the same time from the same community area. To answer this question, please use the rank function. So I need to. Do I need to specify anything or just put rank here? I don't remember now. I need to. Oh yeah, I don't need to. Just. But which one do I pick here? That's the issue. shows the order in which the trees were taken from their respective community areas. So maybe I should put the tree there. Maybe no, maybe just the community area. Because the other ones are time same. Then here I put over and then this clause here. Yeah, I guess like this. Then I don't remember if there is an example that uses rank here. Some count. Yeah, there isn't. There's gonna be partition by, group by, and then what was the other stuff? Or partition by, order by. These rows between unbounded and preceding. That's it. So partition by, I'm not sure, but I think it's this maybe. Then order by the same. The issue is that I don't know how the rank function works. Oops. Maybe now it's correct. Yeah, it doesn't work. So what am I missing here? Maybe we should do select, trip over, then do the function. Trip number, actually. Yeah, I don't want to spend a bunch of time trying to understand this problem. So just gonna look at the solution. Try to finish this as fast as I can so I can finish the computer vision one today. And which I remember that it was uh, probably a lot harder than this one. So it might take me some time to finish, even though there's only 14% to complete. Because I don't remember really well. Or maybe, actually, maybe I didn't complete it because it took a long time to train the net. Just remember that. About it. Just remember. Also, doesn't take any arguments. Yeah, that's what's annoying about these tutorials is that they put some stuff there. Maybe I didn't pay attention and they explain what the rank does, but and I guess that I can they may maybe do that so you look it up, but it's just annoying. So here I have to put test strip number and then I have to take it off there. Well, but here that's weird. Now I'm not sure if I need to erase the stuff they did here. Oh no, it comes after that. Yeah, so this comes after. Comes before. It says amend, so I figured that I needed to complete in the bottom there and not here. But it does make more sense this way. That's why I thought that I needed to put another select there in the bottom. It is still off. So what am I missing here? So from start date. I don't understand. Maybe it's a typo somewhere. It looks like the same, but oh, I forgot the comma here, I think. That's the problem. A damn comma there. Yes. How much time elapses between trips? The partial query in the code cell below shows first trip in the selected time frame, the corresponding taxi ID, trip start timestamp, and trip ends timestamp. Our task in this exercise is to edit the query to include an additional break column that shows the length of the break in minutes that the driver had before each trip started. This corresponds to the time between trip start timestamp of the current trip and trip end timestamp of the previous trip. Partition the calculation by taxi ID and order the results within each partition by trip start timestamp. Some sample results are shown below where all corresponding or all rows correspond to the same driver or taxi ID. Take the time now to make sure that the values in the prior break column make sense here. No, I'm not gonna do that. I'm just gonna. So here's gonna be length, I guess. Yeah. So this is gonna be. But again, I don't know how the length works. And then partition by just copy this stuff here. I don't know if I take the true arguments here or no arguments. So let me try one at a time. Makes more sense that it's true, so I guess. But maybe it's another argument. It's not even here. And then I didn't took the time to read what it was. Yeah, aspirate break is here. First, this function provides the time difference in minutes of the timestamps in the first two arguments. We need only fill in the second argument. Which should use the lag function to pull the timestamp corresponding to the end of the previous strip. So here is lag, and here is the end. The final timestamp. In the second argument, which should use the lag function to put the timestamp corresponding to the end of the previous strip. So maybe I need to get timestamp, but it isn't trip end timestamp the timestamp of the end of the previous strip. Yeah, not sure. So it has one here. There. I don't understand why, but whatever. So there's something else wrong. Petition by taxi ID. Order by. Oh, it did brev break here. Oh, but isn't what the exercise? Oh no, I read the wrong column there. The wrong line. Yeah, so now it should work. Yeah, do I need to save this? Maybe I do. I'm not sure if I saved the first one. Let's see how much time I spent here. 1 hour. Yeah, so it's going relatively fast. Very fast. So maybe I should slow down the next two. I think, yeah, the next one is the third one. So there's two more. Because probably I'll still have time. I think I'm also gonna check here. Because I'm not really sure, but if I remember correctly, I didn't finish this because the exercises were taking a long time to finish the training. But maybe I didn't do them. Don't remember. Yeah, so this one looks partially completed. Yeah, so I think the reason was so I might not be able to finish this. But I'm not sure if this was this one or the computer vision stuff. Let's see if I finish these ones. Yeah, these ones I haven't finished. So it's probably this true that yeah, so I'm gonna have to do them. I think the one that I didn't finish because it was taking a long time was the computer vision, but I might have finished that off stream. Yeah, because the only ones that are still active are these ones. So it must be it. Yeah. Okay. Yeah, so since I don't know how much time this is gonna take, and it's probably gonna be harder than the current one I'm doing, I'm probably better off going faster on this one. Because it's easier anyway. So reduction so far you've worked with many types of data, including numeric types, integers, floating point values, strings, and the datetime type. In this story we'll learn how to query nested and repeated data. These are the most complex data types that you can find in BigQuery datasets. Nested data. Consider a hypothetical dataset containing information about pets and their toys. We could organize this information in two different tables, a pets table and a toys table. The toys table could contain a pet ID column that could be used to match each toy to the pet that owns it. Another option would be BigQuery to organize all of the information in a single table, similar to the pets and toys table below. In this case, all the information from the toys table is collapsed into a single column, the toy column in the pets and toys table. Refer to the toy column in the pets and toys table as a nested column, so that the name and type fields are nested inside of it. Yeah, partially another reason why I'm going fast on this is because I feel like I'm gonna learn more by actually practicing, and it's probably gonna be better to just spend more time with this on an actual Kaggle competition. Because it's not something that is so hard that I kind of need preparation for it. And the other courses in machine learning, I think it's worth it to do this because it's kind of better to prepare my mind to uh, before I start doing the competitions. So I have a sense of what's going on and don't get too lost when I'm trying to do it by myself. So yeah, nested columns have type struct or type required. This is reflected in the table schema below. Call that refer to the structure of a table as its schema. If you need to review how to interpret the table schema, you should check out this lesson on the intro course. To create a column with nested data, we need to identify each field in the context of the column that contains it. Toy.name refers to the name field in the toy column, and toy.type refers to the type field in the toy column. So select name as pet name, toy.name as toy name, toy.type as toy type. Otherwise, our usual rules remain the same. We need not change anything else about our queries. Repeated data. Now consider the more realistic case where each path can have multiple toys. In this case, to collapse the information to a single table, we need to leverage a different data type. We say that the toys column contains repeated data because it permits more than one value for each row. This is reflected in the table schema below, where the mode of the toys column appears as repeated. Each entry in repeated field is an array or an ordered list of 0 or more values with the same data type. For instance, the entry in the toys column for among the dog is frisbee bone rope, which is an array with 3 values. When querying repeated data, we need to put the name of the columns containing the repeated data inside an unasked function. So just type unasked 10 toys. This essentially flattens the repeated data, which is then appended to the right side of the table, so that we have one element on each row. For an illustration of this, check out the image below. So toy type is here, and unasked toys. It destructs, I don't remember how to say that, but basically takes the elements out of the list, as far as I can understand. Then I don't know how, because it seems that like it's messing up the rows here. Or it's just duplicating. So it's still the first row, then the second row. So it duplicates the rows and unnests the data type. This is not a complete query, we just illustrate what this part of the original query does. Let me open the exercise for this. And yeah, 3 out of 4. So there's still this one more. Nested and repeated data. Now what if pets can have multiple toys, and we like to keep track of both the name and type of each toy. In this case, we can make the toys columns both nested and repeated. The more pets and toys table above, name and type, are both fields contained with the toys struct, and each entry in both toys.name and toys.type is an array. So, yeah, I think I understand what it does. And since we give the flattened column an alias of t, we can refer the name and type fields in the toys column as t.name and t.type respectively. So it's accessing the t column there, the flattened column. To reinforce what we've learned, we simply apply these ideas to real data science. So this is the initial code, as usual. Our description, blah, blah, blah. We refer to the browser field, which is nested in the device column, and the transactions field, which is nested inside the totals column, as device.browser and totals.transactions in the query below. So selecting this column, summing transactions, grouping by device, ordered by total transactions, descending. Store the information in the device and totals columns as structs as opposed to separate tables. We avoid expensive joins. This increases performance and keeps us from having to worry about join keys and which tables have the exact data we need. Now we work with the heats column as an example of data. It is both nested and repeated since heats is a struct, contains nested data, and is repeated. Heat number, page, and type are all nested inside the heats column, and page path is nested inside the page field. We query these fields with the following syntax. So I wonder if these structs are unnested several levels above. Probably only one is my intuition, but I'm not sure. Select select hits.page path as path, and counts this as counts, unless hits as hits. Just pretty similar to the previous ones. Just applying this on nest here. Now I have to see if I remember anything from this. Probably not. I think I remember a few things now that I'm getting more exposure to this. It's just the basic stuff. The more complex stuff I'm still forgetting a lot. Who had the most commits in 2016? GitHub is the most popular place to collaborate on software projects. GitHub repository or repo is a collection of files. Okay. First user as a committer. The sample commits table contain a small sample of GitHub commits where each row corresponds to different commits. The code cell below fetches the table and shows the first 5 rows of this table. So just the initial code, I guess. So it creates the object here, then reference to the dataset of this project. Yeah, this I also have to search this up, or how do you create a project and a dataset in SQL? And then gets the dataset ref table, creates the reference to the table, gets the table, and then lists the row with the table. So print write a query to find the individuals with the most commits in the table in 2016. Your query should return a table with 2 columns. Committer name contains the name of each individual with a commit from 2016 in the table. Num commits shows the number of commits the individual has in the table from 2016. So it's going to be select. I'm not sure if I should put num commits here. From this data set here. Yeah, so I don't have the data set. Maybe, yeah, so I need to make it so it's project first dot dataset dot table. But the query to find the individuals with the most commits in this table in 2016. So maybe I should do count num commits. Shows the number of commits from the individual has in table. So let me see if these are columns on the table. Yeah, so num commits doesn't exist there. And I probably gonna have to use a nest, maybe. Just because that's the lesson. So it might be more difficult than it seems. No, I'm not sure. You can find the name of each committer and the date of the commit under the committer column. the name and date child fields respectively. So I'm gonna have to do a nest, computer. Here. Yeah, probably gonna have to do that. Then group by counts descending. So I think I have to use count here, but I'm not really sure. No, it's order by. But here's group by. Yeah, order by counts. I forgot the where here. So no, I actually don't have this information here. That's the issue. So I have to do Joanna's to get the information. So maybe this doesn't make sense here. Maybe the where doesn't is not necessary as well. Yeah, I have no idea. So maybe it's the indentation here. Don't think it should make that much difference. Oh, I forgot a column here. And maybe I need to put a column here as well. No, I don't think so. Yeah, but then why am I on nesting if I'm not gonna use it? Doesn't make sense. And you think I need to access and then use the where somehow? Oh, so here I need to. But if I'm gonna select commuter, oh, maybe yeah, maybe that's correct. Commuter. So I'm selecting this column, then I'm nesting that, then commuter name equals commuter dot name equals commuter underscore name. And Yeah, but the problem is I need to find the ones with most commits. So maybe I need to use that partition stuff and apply a function to get a number of commits. But that feels like it's overcomplicating the thing. Because it feels like it's not supposed to be a big query there. I think I'm gonna look at the hint. And committer.date. Oh, I forgot to erase this end here. Yeah, but now I should use this and make it equal to something. Count the number of rows corresponding to each committer in 2016. Use a raw clause, group layer, and order. Yeah, so this should be this. But date. Yeah, I'm not sure. Because the only way I see of getting the one that has the most is to check for the frequency. Makes more sense. How many times they show up. Making committer.date equals to num commits doesn't make sense to me. Shows the number of commits the individual has in the table. Yeah, I'm not sure. I'm gonna look at the answer. Committer.date. So I don't remember reading that I have to filter by date, but whatever. And it's not using the committer.name. dot name. So maybe that already does the counting automatically. Order by num commits descending. Order by committer. Score name. Oh yeah, here up top. That's where the count is. Which I wasn't sure if I was gonna do there, because I thought that I need to unnest, but apparently also don't need to unnest this. And I need to take this comma off as well. Yeah, so maybe it's because it doesn't have any levels here. It's just a normal object. I just thought I would have to do this because it's the, but maybe it's coming up now. Now we work with the languages table when the code cell below should print the first few rows. So it just creates the reference to the table. Each row of the languages table corresponds to a different repository. The repo name column contains the name of the repository. The name field in the language column contains the programming language that can be found in the repo. In the bytes field, the language column has the size of the files in bytes corresponding to the language. And the following code cell should print this table schema. Okay, so not gonna read this. How many rows are in the table returned by the query below. So now it's using the nest because it's nested. Yeah. Fill the answer. Fill you in your answer in the next one. A nest language. So it's gonna be the sum of this. 1, 2, 3, 4, 5, 6. Probably. Correct. What's the most popular programming language? Better curious to leverage the information in the languages table, determine which programming language appear in the most repositories. The table returned by your query should have two columns. Language name, the name of programming language, num repos, the number of repositories in the languages, table that uses the programming language. Sort the table so that languages that appear in more repos are shown first. It's gonna be ordered by descending. So select. Oh, maybe it has to be language name. Maybe that's what they want. And then count num repos. Count this as num repos. And from this thing where then it's gonna be ordered by languages. Sending group by no order by num repos, descending, and group by language name. So what is the data set here? It's the same one, just change the name of the table. Which is the last statement here. So now I need to think if I use this where or not. Maybe not. Let me try without putting anything. Yeah, so I don't know what you put there. The not thing. I think this part is correct. Sorted by. It has to be where, but what do I put in the where? Maybe it's the data set that I'm getting wrong. Or the count. Could be the count as well. Maybe if I do count repo name instead. That doesn't make sense. Oh, I have to unnest here. That's the thing. No, unnest and the access the name. Select language is language. Yeah, language has language name. Unnest language name as language name. Then yeah, but then what do I filter by? Where maybe I should put language here. Then language. Where language dot name equals language name. Maybe this will work because it's the name is the name of the language. So let me see the hints and try again. The language column contains repeated data. So how do I remove? I remember seeing that. I think I saw the in the previous tutorial, but it was just to append vertically. This union distinct. But you get the unique ones here. It's probably some function that I have to use. And then I have to use the order by stuff there. Did they mention this in the previous? Yeah, they didn't say anything. Maybe in the solution here they talk about it. So I think I'm gonna check the answer, see how often am I. My guess is that I need to use a function to filter for unique ones after the unasked here. Or maybe in the where clause here. or language name, language.name equals language name, and then end language name, then some function, I don't know. Language as one. Okay, so it's as one here. And then I don't need this thing. And here is doing l.name. Also is accessing on top here. And this part is cracked. Yeah, the other stuff is cracked. Maybe not. So yeah, the comma. And take it off here, put here. Yeah, so I need to remember that this and nest is the same. Whenever using the NS, you need to use a comma before on the from statement, so it doesn't think it's the same statement. It's still off. All that name as language name, count as num repos. I don't think it's the uppercase. So what's going on here? Doesn't make sense. Maybe a typo somewhere, a comma that I'm not seeing. What is going on here? I'm just gonna try to copy everything. Might be a typo. Maybe the indentation here that is off. I don't know. Doesn't make sense. And now it's correct. I don't know, I checked a bunch of times. It seemed like I had the correct one. Yeah, whatever. Which languages are used in the repository of the most languages? For this question, we restrict your attention to the repository of name polyrabbit/polyglot. Write a query that returns a table with one row for each language in this repository. The table should have two columns: name, the name of the programming language; bytes, the total number of bytes of the programming language. Sort the table by the bytes column so that programming languages that take up more space in the repo appear first. So I might have to read that again. Which languages are used in the repository of the most languages? Oh, so now it wants me to find the repo. So let me see here. Yeah, so repo name I don't need to announce. I just need to put where there. It returns a table with one row for each language in this repository. Name and bytes. So select repo name as repo from the data set above. Where repo equals this. I think that's what they want me to do. Yeah, but then I need to select the other one as well, the languages, and I'm gonna need to announce anyway. So maybe I do this, copy here, this one. Instead of a nesting to one, I can nest it as language, l.name as language name. Here I don't need this. Here I think I'm gonna do language. So yeah, where this comes on here. With my name, ordered by repo. Ordered by bytes. Yeah, so bytes is language.bytes. I'm not sure hopeful about this, but let's see if it works. Yeah. Getting all of them wrong. Language column contains repeated data. You choose a where clause and an order by clause. So I need to put here one. So I probably need to do it the same way that it was done on the first one. L.name as name, and then L.bytes as bytes. Then I remove this here. It doesn't make much sense, this L.name for me. Because where is the L coming from? I don't get it. Yeah. Or maybe, no, it's not a comma. Maybe it's this string, but maybe just order by name. And then I take this off. The language column contains repeated data. You need to use a where clause and an order by clause. So it has to be the select part. This is a nest.language. This is a nest language I think is correct. Let's try to use language here instead. Caps lock doesn't change anything, but still gonna put it there. Yeah, I don't know. I'm gonna look. So order by l.bytes. Sending. And then you do need to use l.name there. I just don't understand why this is l.name. Makes more sense to me to be language dots because they're accessing the row and the property of the row, but maybe they mentioned it in the description somewhere, but yeah, I don't think it's worth going there and reading this stuff. So again, the same thing is going on here. So can't be just this. Unasked language seems to be correct there. What if I change this? But it shouldn't make any difference. Oh, it's repo here instead. Repo name. It's because I erased the stuff I did before. So that's the problem. Yeah, so let me put the caps lock here, just to see. I don't think it changes anything. It's still wrong. What the hell? What's going on? Is this a 1 or an L? I assume it's an L, but yeah, it should be. So select l.name, l.bytes, from bquery public data, GitHub repos, dot languages, honest language as one. So the only thing has should be this that is different, but our repo name equals polyrabbit polyglot. Yeah, I don't see anything else that is different there. This doesn't make sense. Unless I'm blind or something. Maybe the indentation here is off, but yeah, I don't know. Also, it did change something. Just the indentation here is changing. And now it's correct. Weird. Unless I'm missing something small there, but yeah, I don't know. Production, sometimes it doesn't matter whether your query is efficient or not. For example, you might write a query you expect to run only once. You might be working on a small data set. In this case, anything that gives you the answer you need will do. But what about queries that will be run many times, like a query that feeds data to a website? Those need to be efficient so you don't leave users waiting for your website to load. Or what about queries on huge data sets? Yeah, so this, let me finish this line. This can be slow and cost a business a lot of money if they're written poorly. So this is what I was thinking. I think that SQL is more used for stuff that requires servers and things like that. And then pandas data frame is more of a local thing. But then I'm not sure why I use pandas at all if SQL is more widely used. So it's also from what I remember from the free code camp stuff, it's also a little bit harder to set up SQL and you need to download some stuff. So maybe pandas is just for convenience. I'm not sure. Most database systems have a query optimizer that attempts to interpret and execute your query in the most effective way possible. But several strategies can still yield huge savings in many cases. Some useful functions will use two functions to compare the efficiency of different queries. Show amount of data is scanned, shows the amount of data the query uses. Show time to run prints how long it takes for the query to execute. So it's creating two functions here. Try run equals true. So this shows the amount and this shows the time that it takes. Just by putting start time and then time. Strategies only select the columns you want. It is tempting to start queries with select asterisk from. It's convenient because you don't need to think about which columns you need, but it can be very inefficient. It's especially important if there are text fields that you don't need, because the text fields tend to be larger than other fields. So yeah, significantly lower the second one. In this case, we see a 10,000 10,000x reduction. Read less data. Both queries below calculate the average duration in seconds of one-way bike trips the city of San Francisco. So select mean this. So assume that's everything. If this is the advanced SQL, it's probably everything you need to know. This is drawing, analytic functions, and that's it. Yeah, so I guess that might be one reason why people use pandas, because you can do more complex stuff. But yeah, SQL you probably can integrate as well. But maybe pandas is easier to integrate with Python. Read less data. Before curious, I think I read that before. Since there is a one-one relationship between the station ID and the station name, we don't need to use the start station ID and then station ID columns in the query. By using only the columns with the station ID, we scan less data. Avoid the NaN joins. Most of the joins that you have executed in this course have been 1-1 joins. In this case, each row in each table has at most one match in the other table. Another type of join is an N1 join. Here, each row in one table matches potentially many rows in the other table. Finally, an N join is one where a group of rows in one table can match a group of rows in the other table. Note that in general, all other things equal, this type of join produces a table with many more rows than either of the two original tables that are being joined. Now we work with an example from a real dataset. Both examples below count the number of distinct committers, the number of files in several GitHub repositories. So select, then counts here from the dataset and as repo, then does an inner join on the repo, where if f.repo name in TensorFlow, group by repo or by repo. So this is the big join, this is the small join. Big join and small join. Commit as select count distinct committer names then commit. Yes, I'm gonna go through the exercises. So I guess yeah, this final part is just about efficiency, but doesn't teach anything new. So overall, I think it's a good introduction, but obviously you need more than this to uh, make it natural and intuitive. But at least it was useful to get familiar with the most used functions, most used syntax. You work for Path Customs International. Each write three queries this afternoon. You have enough time to write working versions of all three, but only enough time to think about optimizing one of them. Which of these queries is most worth optimizing? A software engineer wrote an app for the shipping department to see what items need to be shipped and which aisle at the warehouse should go for those items. She wants you to write a query. It will involve data that it is stored in an orders table, a shipments table, and a warehouse location table. The employees in the shipping department will pull up this app on a tablet, hit refresh, and your query results will be shown a nice interface so they can see what customers you send where. The CEO wants a list of all customer reviews and complaints, which are conveniently stored in a single reviews table. Some of the reviews are really long because people love your part customs. I think I'm not, not gonna read this, whatever, get the point. Just gonna skip through. So to me, this is pretty much useless. They're just trying to tell common sense, basically. The only useful part is the and then stuff. But it's also intuitive. Like if you join tables on more rows, it's gonna be a bigger table, which is gonna take longer. So I don't know. I think that's stuff you get with practice. Do the queries run on big or small data sets? So 3 is the answer. Make it easier, blah blah. In solution conclusion. So I think that's it for this course. Now I'm gonna finish the other one. Then tomorrow I can start the free code camp stuff again. Yeah, I think I'm gonna do the Git exercises first, but it's not really hard just to remember the main Git things because I has been a little bit of time since I haven't used it. Okay, so nice. So I'm gonna take a break now, but I think I'm gonna meditate for around 10 to 20 minutes. Then I'll come back and then I'll do the time series stuff. So see you.